Hi, I'm Fishing Paul and welcome to the QMD tutorials series. This series is intended as an introduction to the mod, progressing from the very basic setup needed to begin playing with the mod, all the way to its endgame features. The series structure will be as follows. We will have 4 lessons, each representing one of the tiers of gameplay, and 7 videos associated with these 4 lessons. The first lesson will be all about how to get started with the mod and crafting up our first few resources and the basic processor. The second lesson will be split up into 3 parts. The first part will talk about particles. The second part will talk about linear accelerators, and the third part will talk about the basic particle chambers. By the end of lesson 2, we will be able to craft advanced processors. Using these advanced processors, we will then move on to lesson 3, where we'll talk about the synchrotron, a more advanced accelerator, and using the synchrotron, we'll be able to produce the materials for the elite processor. And then using the elite processor, we will enter into lesson 4, the final lesson, which represents QMD's endgame, and there we will learn about the collision chamber and the decelerator, where we can slow down particles and also collide particles to make more exotic particles. And finally, we will spend our last video talking about the nucleosynthesis chamber, where we can either fuse light elements together to produce energy or fuse heavy elements together to get heavier elements. And then we will also talk about the antimatter containment chamber, where we can store and produce antimatter. So in this first lesson, we will first talk about how can we get some inert gases used both to produce some acids, but also to produce coolants for our accelerators. Then we will talk about how to operate the ore leacher, a machine which does triple ore processing and produces a variety of byproducts required by QMD. And finally, we will also craft an Irradiator fission reactor, which we need to get n-type top silicon, an ingredient needed to make the basic processors. So let's dive into the video. In the air separation facility, we'll collect air with the atmosphere collector, liquefy it with a supercooler, and finally distill it to get a variety of gases used in cooling the accelerators. The atmosphere collector is a machine which collects the air around it at the cost of power, and the more air blocks there are around it, the more air it collects. It looks for air spaces in a 5x5x5 cube, where the collector is placed in the middle of the bottom face of the cube, as we can see by this glass cube right here, and the collector right at the bottom. By default, the collector collects up to 1 bucket per tick of compressed air in the overworld, the nether, and the end, at the cost of 100 RF per tick, and can also hold up to 32 buckets of fluid. So now we've got our compressed air. We then need to liquefy it using supercoolers and then shove it into a distiller to perform cryogenic air distillation. Now, in case you don't know how to build an NCO distiller, I will be linking at the top of the screen a distiller tutorial video. So go there to find out how the distiller works, if you don't know already. But in any case, here we've got a distiller. It is a 5x2x2 distiller with 1 sieve assembly layer and 3 liquid distributors on the ceiling. And this is able to process all of the liquefied air coming from the supercoolers. The liquefied air is then split up into nitrogen, argon, oxygen, neon, and helium. Out of these products, nitrogen and oxygen can be used in the production of acids for use in our next facility, whereas nitrogen, helium, neon, and argon, when liquefied, can be used as accelerator coolants. So for that purpose, I've installed this row of supercoolers so we can obtain liquid gases. And that is all for the air separation facility. Now let's see what the ore leacher is all about. The ore leacher is a very important machine in QMD because by using nitric, hydrochloric, and sulfuric acids, it can break down one ore into 3 dusts as well as other byproduct dusts, frequently dusts that can be used to build QMD components. To produce the above acids, we will need nitrogen and oxygen from the air separation facility, but we also need to get salt. And now I'm going to introduce the liquid collector, the atmosphere collector's liquid counterpart. It works in pretty much the same way, except that the liquid collector is situated in the center of the top face of the 5x5x5 cube, and it also has a biome restriction to where it can collect fluid. This means that In order to collect a certain fluid, you need to have the right kind of fluid, the right dimension, and also the right biome. To get salt, we need salt water, which is collected in the overworld near sea biomes or at the sea itself. Unfortunately, I am in a void biome, so I cannot use it to collect seawater, so I will have to use a creative tank instead. Now that we have our salt water, we then need to get sodium chloride solution. We have two pathways. We can either crystallize the salt water into salt to get sodium chloride, and then we can take this sodium chloride and water, put it in a fluid Leacher, and get sodium chloride solution. The other option is to take the salt water and put it through a distillation multi-block. The second method, of course, takes more space and materials, but it's cheaper and faster. In this lesson, I will go with the first method, because it only takes these two machines. And then, once we have our sodium chloride solution, we can simply electrolyze it to get hydrogen and chlorine, and then we can combine these to get hydrochloric acid. The second acid we need is sulfuric acid. To get sulfuric acid, all we need is to get sulfur by rock crushing granite. I prefer to do that using thermal expansion's igneous extruder to produce infinite granite. Then I crush it to get sulfur. Then I react sulfur twice with oxygen to get the sulfur trioxide, and then with water I turn it to sulfuric acid. And finally, we need to produce nitric acid, which we do by combining nitrogen and oxygen from our air separation facility to first make nitric oxide, then nitrogen dioxide, and then we react it with water to finally get nitric acid. And now have all three of the acids that we need to operate the Leacher. And now we're almost ready. We just need one final ingredient, the N-type doped silicon, to end the lesson. So now let's go build our Irradiator nuclear reactor. So the way we produce N-type doped silicon is to shove silicon into an irradiator inside a fission reactor. I'm going to make a small, cheap, and tileable design using Lu-235 nitride, which can make one N-type doped silicon every 42 seconds per active irradiator. In front of me, I have a shell for a 6x2x4 fission reactor. Let's get the materials here from this chest. We first need to get a cell, a reflector, a moderator, the irradiator, and some heat sinks. Let's start by placing a cell here in the corner. Then, in order to be able to activate the cell, the heavy water moderators and a beryllium carbon reflector, and then a line of 4 heavy water moderators leading into the fission radiator. For cooling, we can simply place a lapis sink above the cell, then an iron sink above the moderator, and a lead sink next to that iron sink. And now this cell is now completely cooled. Now let's take this design and mirror it diagonally. So we will place a cell right here, 2 moderators and a reflector to activate the cell, and then 4 more moderators to have an radiator line. Place again a lapis sink, an iron sink, a lead sink, and the design is pretty much ready to go. Now we need to place the other auxiliary blocks. And now our irradiator reactor is ready to go. We just wait a few seconds and we should see an N-type doped silicon spawn right on this cache. Here we have the reactor stats. The net cluster heating is negative, so we are in a good spot. It's not producing a very significant amount of energy. That's okay, we don't use it for energy anyways, we use it just for irradiation purposes. As we said, we produce one N-type doped silicon every 42 seconds for every single irradiator that's operational. We have 2 radiators, we produced 2 N-type doped silicon. Of course, we can just tile up this exact same design vertically to produce more if we want. And so we now have N-type doped silicon, we have all of our inert gases, we have our acids, so I believe that means we have everything we need to get to the next lesson. So let's go to the outro where we will do a little recap of what did we see in this lesson and what to expect for next lesson. So now we should have everything we need to begin our QMD journey. We have various inert gases for accelerator cooling, we have QMD ingots to craft accelerator blocks, and we have N-type doped silicon to craft basic circuits. I hope this video has been helpful in understanding QMD, and I will see you in the next tutorial. Goodbye.